In this lecture, we will discuss what is bilinear form, the definition of bilinear form, and then we will see some example on bilinear form. So, let VF be a vector space. Okay, then a bilinear form on V is a function. Okay, what is bilinear form? Bilinear form is a function whose domain is V cross V. Okay, so domain has element like u comma v, where u belongs to vector space V and V belongs to vector space V. Okay, and codomain is field, where vector space V is defined. So bilinear form is a function from V cross V to F, and there are two conditions on that function. Is first condition is एफ यू प्लस लेमडा भी. यहाँ u जो है ये कहाँ का एलिमेंट होगा? v का एलिमेंट है, एंड v भी कैपिटल v वेक्टर स्पेस का एलिमेंट है, एंड w बिलोंग्स टू कैपिटल v. देन हम लोग क्या जानते हैं कि v एडिशन के सापेक्ष क्या होता है? क्लोज होता है. मीन्स u प्लस v बिलोंग्स टू v, एंड स्केलर मल्टीप्लिकेशन के सापेक्ष भी क्लोज होता है. मीन्स डेट u प्लस लेमडा v बिलोंग्स टू v. मीन्स दिस एलिमेंट will belongs to v. Okay, so this element belongs to v, this element belongs to v. So we have a functions from v cross v, and image element will be in f. Okay, field member, and the condition is that f u plus lambda v comma w equal to f u w plus lambda f v w. Okay, and the second condition is f u comma lambda v plus lambda w equal to f u v plus lambda and f u w. Okay, so functions on v cross v to f should satisfy these two conditions. We call that function a bilinear form. Okay, तो उस फंक्शंस को हम लोग क्या कहते हैं? बाइलिनियर फॉर्म कहते हैं, जहां पे u v w belongs to vector space and lambda belongs to field. Okay, so everything should be clear till now. Okay, and please subscribe my channel if you haven't subscribed yet. Okay, it is very helpful for me. Okay, now since it is linear in both coordinate, okay, f is linear in both coordinate. Here, what is linear map? Linear is x plus y equal to fx plus fy. Means we have only one coordinate here in linear map. We have learned in my previous lecture. You can visit there. And here we have two coordinate, first coordinate, second coordinate, and f is linear in both coordinate. That's why we call it bilinear form. Okay, so now we will see an example what is bilinear form. So assume V is a vector space R, and field is also R. R is the set of real number. So we can define the functions from V cross V to field member. Here R is a field and V is R. So we can take two element x y belongs to R. This is a vector, this is a vector, and we can multiply this, and this belongs to R, means field member. Now we can check that it is bilinear form. So first it should be a function, because any element of R cross R is of the form x comma y. So every element we have an image in this. And now check, any one element should not have two images. Okay, one element should not have two images for a function. Okay, firstly we will check that this is a function, and then we check the linearity of the first coordinate and the second coordinate. Okay, so assume x1 comma y1 equal to x2 comma y2. This will imply फर्स्ट कोऑर्डिनेट x1 x2 के बराबर होगा एंड y1 y2 के बराबर होगा. Okay, so how we can write here? F need to show what? Need to show, because this is equal, so image will also be equal, means fx1 comma y1 should be equal to fx2 comma y2. So we can take here fx1 comma y1, it will be x1 into y1 by definition of this. Okay, we have given from 1, we can write here from 1, and fx2 comma y2, what it will be? X2 into y2. Okay, from 1. Now we can see here x1 equal to x2 and y1 equal to y2, means RHS of both the image is equal. Okay, this will imply fx1 comma y1 equal to fx2 comma y2, means that whatever we have defined here, this is a functions from r cross r to r, and this is field, and this is v cross v, where v is r. And we have seen that Rn over R is a vector space. Okay, or n belongs to natural number, so we can have R over R is a vector space. Okay, so now we will check first. What we will see that f u v plus lambda w should be equal to f of u comma v plus f of lambda into f of u comma w. This is should be equal, means linear in second coordinate. So take u equal to x1, v equal to x2, and w equal to x3. These are from real numbers. Okay, these are real numbers, so we can have now in RHS we can write here x1 u, value of u is x1 comma x2 plus lambda x3. Okay, we have taken v2 is x2 and w is x3, so we can put here in this equation, and we will get what we will get here. By definition we can write x1 multiply by x2 plus lambda x3 by definition of function, and we can write here, since this is a real number, so we can write x1 into x2 plus lambda is also a real number, so we can write here x1 into x3, and this will be equal to f of x1 comma x2, because f of x1 comma x2, it will be what? By definition of function x1 into x2, so we can write fx1 x2 in the place of x1 into x2. Okay, and this can be written as fx1 comma x3, and this will be equal to, we can write here f of u, value of x1 is u, this is v plus lambda f of u w, and this is what? This is f of u comma v plus lambda w. So what we have here proved that f u comma v plus lambda w equal to f u v plus lambda FUW. Okay, and second thing we have to prove linearity in first coordinate. So this is also easy to prove that f of u plus lambda v comma w equal to f of u comma w plus lambda f of v comma w. We have to prove this statement. Okay, so LHS, what we have is u plus lambda v comma w, and we know the value of u, v and w, so we can put here. So we have x1 plus lambda x2 comma x3. Okay, and now by use the definition of function, it will be x1 plus lambda x2 into x3. And now since this is a real number and this is a real number, we can have x1 into x3 plus lambda x2 into x3, and this is nothing but f of x1 x3 plus lambda f of x2 x3. Okay, and this can be done f of u comma w plus lambda f of u comma v comma w, because of value of u is x1 and value of w is x3, value of v is x2 and value of w is x3. And what we need to prove, u w plus lambda v w. Okay, hence this will imply f x comma y equal to xy is a bilinear in v, where v is r. Okay, yeah, we can write here on. Okay, so we have proved this, and we will see some examples and some types of bilinear form in next lecture. Okay, thank you for watching.